Okay, so here I'm looking for something to hold up this 60-pound sign. So I have a 60-pound whatever weight here. Okay. Now I have some reaction components. So if I'm just drawing for this system with the smooth color A, why does it say that twice? Oh, the reaction component, forces and reaction moments. Okay. So basically, what I'm going to do is I'm going to assume that this thing here is one giant whatever. So I don't care about what's happening at the connectors, like here and here. I'm just looking at the whole thing. So the forces that are going on is I have a tension here. I have a tension here. And then along A, I'm prevented from moving this way, and I'm prevented from moving this way. Let's see, I'm prevented from moving this way. I'm also prevented from rotating around the A, and I'm prevented from rotating around the Y. So I have a force, I have an AX, I have an AY, hard to see, and then I have a moment about the X, and I have a moment about the Y. It's kind of hard to get them all labeled in there. So, moment about the Y. Okay. Because I'm not really sure what to do, I'm going to figure out what my tensions are. So, the tension from B to C I have to get by erasing all that, first of all. So probably one of the more annoying parts of this is figuring out what all these stupid position vectors are. So for lack of anything else better to do, I'm going to try to figure out the tension from B to C. So to do that, I'm going to go R from A to B, I'm going to go R from A to C, and I'm going to subtract them. So to get from A to B, this is actually along the same XY plane. So I'm going which way along X to get to B? I have to go backwards along X. So I go backwards 2 feet to get to B. So I'm going -2 in the X, nowhere in the Y, and wait, not nowhere in the Y. I'm going somewhere in the Y. I'm going out along the Y. I'm going out 2. And then I'm going nowhere up and down. So I'm in the XY plane. Okay. And then for the AC, to get from A to C, I am going backwards, -3. I'm going nowhere in the Y, and then I'm going up 2. Okay, so to get the position vector from B to C, I'm going to go R from A to C minus R from A to B. So that's going to get me, why is this difficult? -3 minus a -2, 2, why am I doing this backwards? No, I'm not. 0 minus 2 and 2 minus 0. Okay, so that gives me 1, -1, -2, 2. So the unit vector from B to C is going to be that divided by its magnitude, so that's 1 plus 4 plus 4, which is my favorite square root. Okay. So this is going to be all those divided by 3 minus 1/3 minus 2/3 and positive 2/3. Okay, so that's my unit vector in the one direction. And I'm thinking that it's not symmetric, because that would be too easy. So really the only thing I need from here right now is that my tension from B to C, so I'm trying to find the tensions on each one of the cables. So the tension from B to C is going to be negative TBC over 3, negative 2 TBC over 3, and positive 2 TBC over 3. So those are the TBC components. So Now that I don't need any of this junk, I can kind of throw it off to the side. And this guy, I'm going to keep for later, but he's not going to take up any screen space because I think I'll need all the screen space I can get. So now I'm going to do the other tension. So I'm going to do the tension from D to E. So in order to do that, again, I'm going to go R from A to D, R from A to E, and I'm going to subtract the two from A to D and D to E. So to get from A to D, I'm going to go 3 feet forward. I'm going to go 2 feet out and no feet up and down. And then for A to E, junk everywhere. For A to E, I'm going to go forward 4. I'm going to go 2 up. Well, that's 0 out and 2 up. Sorry, 0 out and 2 up. So to get from D to E, I'm going to go AE minus AD. So that's going to be 4 minus 3, 0 minus 2, and 2 minus 0. So that's positive 1, negative 2, and 2. So unit vector from D to E is going to be that divided by its magnitude, which is 1 plus 4 plus 4, which is again 3. So 1/3, negative 2/3, positive 2/3. D to E. So the tension from D to E is going to be T dE over 3, negative 2 T dE over 3, and 2 positive 2 dE over 3. So now that I have that, I can throw the rest of that away. Not really away, but I certainly don't need it for a while. I'm going to throw this over. So now I've got this little tension that I had before. And this one thing. So these are helpful. So let me do stuff with these. Yay! Okay. So as I'm going along, the fun part is going to be adding all this stuff up. Okay, so I know that the sum of the forces in the z direction are going to equal to 0. So I don't know if that's going to be the easiest one to do, or if it even matters. I don't guess it is. I'll just start x, y, and z. Alright. Sum of the forces in the x are ax. And then these guys. Minus tbc over 3 and plus tde over 3. Why did I do that? Plus that equals 0. Okay. Some of the forces in the y are ay minus 2/3 tbc minus 2/3 tbe, or de, equals 0. I can't help it write large. Some of the forces in the z direction are, I've got 2/3 tbc, 2/3 tde, minus 60, and that equals 0. Alright, so those guys are set. Amazing. I'm exhausted. Okay, now I have to figure out what I want to take the moment about, because I don't think any of these are going to be particularly fun. Okay. So I think I'm going to try something a little different. So what I want to do is I want to find the moments caused by TBC. So the moments caused by TBC about A. Okay. So to find the moment that TBC causes about A, I can cross TBC with a position vector, any position vector I want that starts at A and goes anywhere along the line of action of that. So I'm probably going to do is going to be, I'm going to do R cross TBC. And the R I'm going to pick is going to be R from A to C. So I happen to know that R from A to C, because I did it earlier, is -3, 0, 2. I'm going to cross that with basically that I did earlier. And because I'm lazy, I'm going to put this in my calculator. Instead of TBC, I'm just going to say X. So I have -3, 0, 2. And then I have -1, -x over 3. -2x over 3. And 2x over 3. And I'm going to cross those. No, not that. I'm going to R cross X. So 4/3, 4/3, and 2. So I get 4/3, 4/3, and 2. Okay? This is a little weird, but this is just another way to solve it. So I'm just trying to be as useful as possible. Okay. So that's the moment of TB. That's the moment that force causes about A in all three directions. I'm going to hide this and save it for later. All right, now I want to find the moment that T from D to E causes about C, or about A. So again, I can do this by going the R from A to E, or I could do R from A to D, it doesn't really matter, and cross it with T, D, E. So R from A to E, I figured out earlier, was 4, 0, 2. I didn't say that this wasn't tedious. TDE, -2 TDE, and 2 TDE. Okay, so I have 4, 0, 2. And I'm going to cross that with x thirds, -2, x thirds, +2, x. Why was I confused? Thirds. It's a different x, I'm just lazy. But that looks right. So now I'm going to cross these guys. Cross ball, R cross x, not x cross y, R cross x. So this moment is going to be 4/3 TDE, -2 TDE, and -8/3. Okay, so that's that. There's only one more that I have to worry about if I'm taking the moment about A, and that's going to be the moment caused by for G about A. Okay, so G, I just need to get from A to G somehow. So to get from A to G, I'm going to go how do I do this? I'm going to go along the, 2.5 along the X. I'm going to go actually down 1 foot. Well, that's X. That's nothing. Then I'm going to go out 2 along the Y. And then I'm going to go down 1 in the Z. So I have to cross that, cross with G, which is 0, 0, -60. So this is an actual number. Amazing. Okay, so I have 2.5, 2, -1, and I'm going to cross that with, which I could probably do in my head, I just don't feel like it, those two. Power cross that. No! That. Okay, so that's, what did I say? Negative 120, 150, and 0. Okay. So why did I care? Why did I do all this stuff? So that goes with these guys. I'm going to move him completely out of the way now because I don't care anymore about those. I don't really know how you keep this tidy on your own piece of paper because I'm not doing it on my own piece of paper. So basically what I know now is I have these moments. These are all things that are causing moments, all the forces that are causing moments about A. So that means that the sum of the moments about A in the x direction are 4/3 TBC, 4/3 TBC. Oh gosh, I'm running out of space. Hold on, let me fix it. Okay, so 4/3 TBC plus 4/3 TDE minus 120, and then I also have that moment in the x direction right here. So those are all the moments about x, and that has to equal 0. Now I have the moments about A in the y-axis. Those are 4/3 TBC minus 2 TDE minus 2 TDE plus 150, and do I have a y one? I do have a y one, plus moment in the y. Isn't that beautiful? I'm exhausted. I think I'm happy with that. Wait a second. I think I did something dumb. This right here? That's not the whole thing, because that's being measured from the end, which is being measured from here. Oh, that's annoying. So that distance here is not exactly 2.5. It's actually 0.5. So let me do that again. So it's really 0.5 to -1, and now I'm going to do the cross. So what you get, being an engineer, minus 120, 30, and 0. Okay. But it doesn't really change much. All it changes is this number right here. 30. Okay. Now I'm going to do the sum of the moments about A around the z-axis. And those values there are 2 TBC minus 8/3 TDE. This one's 0. There is no moment reaction, and then all that's 0. Okay. So now I have all these equations. This is going to be amazing. And by amazing, I mean desperately tedious. Okay. So what I'm going to do is I'm going to put these in a specific order. I'm going to go TBC, TDE, MX, MY, AX, AY, and they're all going to equal some constant. Constant, that's supposed to be not a 0. Constant. Okay, so the first one is 4/3, 4/3, 4/3, 4/3, MX is 1, and the 120 is going to move to the other side of the equation to become a positive 120. So 120. Okay. Now the second equation. 4/3 minus 2. 4/3 minus 2. My is 1. And then this 30 is going to get moved to the other side. So it's minus 30. Now, the next one is 2 TBC minus 8/3 TDE, and that equals 0. Alright, now the next one is, I'm just drawing the lines to keep it straight, is AX minus 1/3 TBC plus 1/3 TDE, and that's 0. Then I have a y, 2/3 minus 2/3 TBC minus 2/3 TDE, and everything else is 0. And then 2/3 TBC, 2/3 TDE, and then the 60 is going to get moved to the other side to go 60. And then everything else is going to be 0. Now, theoretically, all I have to do is stick this into a calculator, reverse row echelon it, and hopefully it doesn't blow up in my face. So 4/3, 4/3, 1, 0, 0, 0, 120. 4/3, -2, 0, 1, 0, 0, minus 30. 2, -8/3, 0. And then lots of zeros. 1, 2, 3, 4. -1/3, 1/3, 0, 0. 1, 0, 0. And then 2. Oh, I'm about to do it again. Minus 2/3, minus 2/3. 1, 2, 3, 1, 0. 2/3, 2/3, 1, 2, 3, 4, 60. Oh gosh. Comment. Oh. Okay, so I'm going to pause it while I figure out why I can't enter things into calculator quickly, and I'll be right back. Okay, having fixed that problem, Pachonk, I reverse row echelon it. Reduce row echelon? I something row echelon it. Oh, I need to do it better. And I should get myself some pretty answers, which I do. So I have 51.4, 38.6. Zero, -21.4. 4.23. And then I can't see the last one, so I'll just come down. Oh, it's 60. 60. So that's the last one. So those are my values. So TBC is 51. This guy is this guy, and this guy is this guy. So really, I guess the theme of these problems is you just gotta want it. 6 equations, 6 unknowns, and it's super duper fun. There you go.